Which one is the best black ABS filament? And I have here 8 brands. Let's find out together. Welcome to my tech farm. In this video I'll compare 8 black ABS filaments from different brands. If you're not familiar, ABS is very popular material for printing mechanical parts. Compared to the PETG, it has a high temperature and impact resistance. It is tougher material, but it is harder for printing. It warps and requires enclosed printer. For example, in a car, injection molded elements are made from the ABS. Another example, Lego with their quality became famous because they started using ABS at that time. And many DIY printers, for example Voron, requires a black ABS as a base. Then you can use some other colors too, but that's why I decided to test exactly the black color. I already mentioned earlier that the Polymaker is the channel sponsor, and actually they asked me for this video. And reason for this is that they have their old ABS, which has less smell and it is easier for printing, but with this they sacrifice some mechanical properties, and they are working on ABS Pro now, which will be for professional users without this compromise. Because usually the professionals solve this exhaust fan. For example, my X1 Carbon is connected to the ventilation hole on the wall, and I can have even an enclosed printer with the heated chamber if necessary. That's why they asked me for this video, to have documented the specifications of their old ABS compared to the other filament brands. And don't worry, this sponsorship don't have any effect to my measuring results. Just in case, I want to show you every measuring in the video too. Let's see the filaments from this video in ABC order. AzureFilm ABS Prime, BambuLab ABS, eSun ABS Plus, FlashForge, FormFutura TitanX, Polymaker PolyLite ABS, Sunlu ABS, and YXPolyer ABS, also in black color. And in this video I want to compare mechanical properties which are important for this ABS, the advantage compared to the PETG. For example, the creeping, stress relaxation, temperature resistance, but of course layer adhesion, tensile strength will be tested too. I collected some print settings from their website. Two most important are these, the print temperature and the bed temperature. And this is what I will use, generic ABS profile, 270 on the nozzle and 90 on the bed. I will show you later the slicer settings. And the price, well, usually I can see only the price for me in the EU. And I converted this to the dollars and I calculated it dollar per kilogram, because some companies don't have 1 kilogram spool but smaller. And if I can see the price in the US, you can see it in this column. Let's see the test objects from this video. I will have 3 for the temperature test, but with the different loads, since this is an important property of ABS material. Creep test, stress relaxation, tensile test. These are a little bit longer than my typical test objects. I'm not sure if I will prepare my new tensile testing machine on time. In that case, I want to measure some prolongation too. And then 3 for the ISO, then 3 for the Sharpie impact testing. This is for the bending test, layer adhesion. But these are printed with 2 walls and 20% rectilinear infill. All others are solid inside. This is for the bending test, hook test, where I will measure the brake load. And this is also S-hook test, but a little bit different. They will be connected to each other. I will pull them, and always the weakest will fall out. And at the end, we will have a winner. First 4 filaments are loaded into AMS2 Pro, AzureFilm, BambuLab, eSun and FlashForge. Drying will be on 65 degrees Celsius 8 hours. The start is good, and I have a feeling that this part will be very boring, so I'll try to speed it up, because this printer handles very good the ABS material. Only that ventilation is not completely solved here. Well, everything will be so big work here, even only marking them with the white marker. AzureFilm printing is finished, and I rated the smell when I opened the door on scale 1 to 3. This is 1, not too strong, quite weak smell. Of course the adhesion is strong until the bed is hot, and when the bed cools down. BambuLab, and this smell is stronger. From 1 to 3, this is number 2. It cooled down overnight. Oh. eSun, and usually when I came into the room to check the printing, I can feel the smell of the ABS, and here, like with the AzureFilm, is very minimal. Rating 1. And during this printing, I'm drying the next 4 filament on H2D. eSun is finished too. FlashForge, and the smell is very similar to the BambuLab ABS, so on my scale from 1 to 3, it's number 2. The first surprise during the printing, some warping appeared on the impact test objects. Now I can see the possible reason for this warping. I just wanted to take out this bed and they removed. Yes, they have a much weaker bed adhesion. Look at this, but the bed is still hot. So only these 3 test objects are affected by this warping on this side only. So this means for the ISO testing they'll be fine because they'll be holded on the lower part and the cross section is unchanged. All other objects are perfectly straight, no warping. Now maybe it is partly my mistake because officially they recommend 100-110 degrees Celsius on the build plate and I use 90, which is the default for the generic ABS. But I'm using the same settings for all 8 ABS filaments. Next 4 filaments are loaded: FormFutura, Polymaker, Sunlu and the YXPolyer, and some of them got this ring because they are on a cardboard spool. FormFutura, the smell is not too strong, so my scale rating 1, and I think they have some kind of anti-warp technology, so it is even printable on open printer, but if it is similar like their ASA, then they sacrifice some mechanical properties because of this. Polymaker, the smell is very minimal, less than BambuLab, but a little bit more than, for example, with the AzureFilm. Sunlu, and through these doors I cannot even feel the smell of the ABS. YXPolyer, and also with hardly noticeable smell through the closed doors. It cooled down overnight. With every printing we can see a difference between the faster printing and slower printing, and I'm not sure if you can see this on the screen too, but biggest difference is with the eSun filament. This is the shiniest and most matte surface, and the smallest difference is with the YXPolyer, this one here. Only now, seeing the number of the test objects, I realize how big this fork will be. Quickly to check the shrinking, they are printed in this position and I will measure about the elephant foot. The design length is 80 millimeters. I mentioned that I'm trying to show every measuring in the video too. Just jump few seconds if it's boring. Typical shrinking for the ABS is around 0.5%. This would be 79.6 millimeters in this dimension, and more or less they are here. What is surprising is FormFutura has the biggest shrinking. This means probably it is not so easily printable on open printer. Definitely this is very different filament from their ASA version. The tensile test with horizontally printed objects, 4x4 millimeters in the smallest cross-section area. And my new tensile testing machine is not prepared, so no prolongation is measured. And I have no energy to search for the background music, just enjoy the noise of the brake. Most of them are very close to the average line. The AzureFilm was the best and the YXPolyer was the weakest in this test. Layer adhesion test with vertically printed objects, 10 by 10 mm on smallest cross-section area, but printed with 2 walls and 20% rectilinear infill. This time we can see a bigger difference between these materials. This is the average line and the weakest now was the eSun, and 2 best are the Polymaker and YXPolyer. The hook test, where we have the combination of the tensile and the bending stress. It is solid inside and I'm measuring the brake load. This time the numbers are much closer to each other. This is the average line, and we can see 4 a little bit above it and 4 just a little bit below this average line. And now the elimination test, where the weakest S hook will fall out, and at the end we will have the winner. AzureFilm fallout. I like this test, but I have to figure out somehow to do it in some enclosed area. Sunlu fallout. Because sometimes it was extremely hard to find all pieces. Polymaker. FormFutura YXPolyer BambuLab FlashForge. So the winner is the eSun, but let's measure this one. I like this testing, it's fun, but sometimes it was very hard to find all pieces. They just fly away after the break. And now the impact test. I am starting with a Sharpie hammer, and the test object is supported from 2 sides. And this part will be very boring if I show you every measuring. I will just show you one and then 8 pictures with 3 measurings on the screen. I'm starting with AzureFilm. Currently this is eSun. I already measured 2 quite tough material and I want to show it in the video. FormFutura, this looks tough too. Polymaker, the channel sponsor, just 1 measuring. So this was the Sharpie testing, object supported on 2 sides, and in the right upper corner you can see 3 numbers, that's in kilojoules per square meters. Result for the Sunlu and YXPolyer. Replacing the hammer, switching to the ISO testing method. Test object is now in the vertical position. eSun, and I want to include this first measuring. FlashForge with that warping, but it will be on top part. This is unchanged. Somehow in this test the FormFutura is extremely strong. Polymaker, the third measuring. Around 16. And this is the very last measuring. I want to include it in the video. YXPolyer. Around 17. Picture for the documentation and the results. BambuLab, eSun, FlashForge, FormFutura, Polymaker, Sunlu, and YXPolyer. These are 2 different tests and I shouldn't place them on the same graph, but for the comparison it will be nice. And these are the average lines, and look at this, eSun and FormFutura are so tough that they completely move these average lines. But don't be confused, even this AzureFilm is tougher than, let's say, PLA or PETG. In this small corner in our winter garden, I got the permission from my wife that I can place here my test objects and they can stay here 1 week. And I will not measure them every day, only now initial deformation and after 1 week. As you can see, typical temperature here is around 20 degrees Celsius. Crimping is a deformation under constant load, in this case 1.25 kilograms. I'm placing the weight and immediately I'm doing the measuring. They measured, this is the initial deformation and more or less very similar values except on one filament. On FormFutura a little bit more deformation, but I already mentioned this that it looks like this is highly modified ABS for better interpretability, but they sacrifice some other properties with this. And I will measure them in 1 week. And now after 1 week, let's measure them again. Again a time-lapse video. If you didn't saw this measuring earlier, I'm locking the position for more accurate measuring, and I'm measuring the distance between 2 reference surfaces. And visually their permanent deformation is very similar. I think low crimping is important property of ABS materials, one of the reasons why we want to go with the ABS instead of the PLA or PETG. And with the blue, this is initial deformation, distance between 2 reference surfaces, and with the orange, this is a deformation after 7 days, And the difference between two in percentage is marked with this yellow point, and 6% is the average. So in this case, worst scraping was by the eSun and FormFutura, and two best are FlashForge and Sunlu. And now 3-point bending test, where we place this load and measure the deformation after exactly 30 seconds. This setup follows better the ISO standard with this distance of 64 mm and these diameters of 10 mm. AzureFilm, BambuLab, eSun, FlashForge, FormFutura, Polymaker, Sunlu, YXPolyer. And visually no permanent deformation on any of them. I think this property is also important for ABS materials. This is the average line, and two worst are eSun and FormFutura, and two best BambuLab and FlashForge. Stress relaxation test. I have these M5 bolts, and I will tighten them with exactly 2 Nm, and after 1 day I will measure the untightening torque. Tightening time-lapse not so interesting, but don't worry, the untightening will be speeded up too, but not so much, so we'll be able to follow it. AzureFilm 1.6, 1.5, 1.4, 1.2, eSun 1.4, 1.4, FlashForge 1.3, 1.6, FormFutura 1.1, 1.1, Polymaker 1.2, 1.1, Sunlu 1.3, 1.2, YXPolyer 1.1, 1.4. And now let's evaluate the result. The average was 1.31 Newton meters, and we can see that in this case the AzureFilm was the best and FormFutura was the worst. And now temperature tests, 3 types. The first one without load, actually their own weight will be the only load, and the alloy extrusion will be slightly tilted, so they will start to deform in the same direction. In this test I just want to record the order of the deformation. This thermometer is accurate, but it has some delay, so I will not use those numbers. In the second test, the load will be approximately 0.5 megapascals, which is just a little bit above the load used in ISO 75 standard. The weight is 50 grams multiplied g acceleration. This gives us 0.49 newtons. The lag from the edge of the alloy extrusion is 55 millimeters, and the cross section is 20 by 4 millimeters. And with this the bending stress is approximately 0.5 megapascals. In ISO 75 they are using 0.45, which is quite close. And because of the bigger load, several objects started to deform at the same time, and you can see the order on the screen now. And this is my regular testing method. The weight is M10 nut, and the load is approximately 1/4 from the previous. And this time I'm using accurate thermometer to record the temperature of the first deformation. But I will record the orders too. At 118 degrees Celsius I stopped the experiment. I just want to check how soft are they now. And for the touch I could feel some difference, but it is better to stay with the measurable numbers. Now let's try to summarize the results. So in these 3 columns we can see the order when it started with deformation, and in all 3 cases, for example, the FormFutura started to deform first, so smaller number is worse. And here I calculated the average number from these 3. I will need it later when I calculate the points for the best filament. This is in degrees Celsius and similar on this graph. So on the left side we can see the order. We can see some jumps here, for example AzureFilm here because it started to deform in the same time with other filaments, and this yellow point is degrees Celsius. Remember, at the beginning of the video I promised you to find the best black ABS filament, But first, let's see all the results at once.
Tensile test, layer adhesion, hook test, elimination S hook, impact test Sharpie and ISOD, creep test, 3-point bending test, shrinking and temperature test, all three, stress relaxation test. And now the scoring. In this table I summarized all results. Worst value is 1 point, best value 5 points, and anything between, proportionally between 1 and 5. So this is calculated value. Of course I took in account that sometimes the smaller value is better, and I think only for the shrinking the point was between 1 and 3. To be honest, for the layer adhesion I would give something between 1 and a 10, but let's keep it constant. And when I summarize all the results, this is the final score. So the average is approximately 32.7 points, and more or less all filaments around here. The FlashForge is the best. Even I took down 2 points because of that significant warping. This was the only filament where I had the problems during the printing. And from this 8, in this case, the FormFutura is the worst. But as I mentioned, all other more or less around average value. But as I mentioned, none of them is perfect. For example, if you still need an impact resistance, in that case FormFutura is far the best from this 8.
This was my biggest work so far. I was working on it few months, not continuously, but I'm afraid that the algorithm will not really appreciate this amount of the work. But huge thanks to the Polymaker and to the Patreon supporters, because without them, I'm curious about this myself, but only with reduced number of the test objects this was too big work. And looks like I'm not learning from my lessons, because I have here a box with the 16 transparent PETG filaments, and something similar I want to do with them. But maybe with a little bit reduced number of the test objects we will see soon. So like, subscribe, high button. Thank you for watching and happy printing.